It's time. Some of you already went ahead and did this, but those of you who are paying attention to the scope and sequence of the class, this is the moment where we get back into the calc bad and we go ahead and get some horizontally launched projectiles. We got a couple questions over here for this first one. And while I go through this, I draw a scenario diagram. I'm given the initial height. I'm given the initial x velocity. I'm given the initial y velocity as well. And actually, I can change that because it's launched horizontally. I already know it's going to be 0. And they tell me that if they say thrown horizontally, v0y equals 0 every time. I know my velocity in the x position because that's the only velocity that I have. This, because it's launched horizontally, Vx is going to be this number because it's horizontal, and then that's the only speed that I can have. So now, first question for A, how much time does it take to get to the bottom of the cliff? Then B, how far does it go? C is, what is the final velocity when we get there? And we're going to see that. And then D, finally, what is the final y velocity? When it comes to trying to find the time, you got to go in the y. Pretty much every time. Get it? If you don't have the final velocity and you have everything else, you have the position, that we have to use the second y kinematic equation. So that'll be the delta y is equal to v naught y t plus 1/2 a delta t squared. And when I isolate time like this, I end up getting this right here. And I know what my starting height was, and I know what the acceleration is because it's always -10. -9.8 for the physics classroom problems. When I plug things in, boom. Don't forget the square root. I forgot the square root at first. I'll admit it. Should be square root second squared. Meters cancel out. Anyway, we move on to part B. How far from the base of the cliff, or XF? If it's the X formula, I have to go into the X equation. And remember, of all my equations, I only have one equation. I only have one X equation. So that makes it easy to remember. Delta X is equal to Vx delta T. Delta X is equal to Vx, and then I can plug in what I had from before, but you already know what delta T was, so you could just go in and plug in numbers. But I'm not a buster. I'm plugging numbers. I don't do that. Then we go into question C. What is the horizontal velocity? Horizontal velocity, it doesn't change. They gave it to me in the beginning, but it doesn't change. So it's going to just be 11.3. Easy. What's the vertical component before it hits the ground? Right before it hits the ground. But you can essentially say that over here, the final height at this point, right before it hits the ground, it will be 0. Accept that. Accept that in your heart. And this class becomes easy. So for part D, you get to pick. Oops, that shouldn't be there. Oh God. Oh heavens. Whatever. I have everything. I have delta T, I have Y, I have V naught Y. I got lots of things. So I can solve for VF Y any way that I want. And if I have all those options, I'll pretty much always pick the first formula because it's the easiest. VFY is equal to, V naught Y is gone because it's launched horizontally. VFY equals to A delta T. This is what happens when you're a chancellor and you actually plug in the numbers all the way, or you don't plug in the numbers. But for busters, we come over here. Sorry, survivors, we come up over here. The acceleration -10 times 4.1, 41 meters per second. Negative. Now, the next type of problem is a doozy. This was a cliff problem because we had an object that is launched horizontally. But now, we finally have it. We have a catapult problem or something that has a launch angle to it. We have an object that has a launch angle to it. And first, what ends up happening is they give us the starting velocity and they give us the angle. On my scenario diagrams, I pick 3 important points: the start, the launch, the peak, and the landing. Those are the 3 important parts. And what you'll see is when you use the peak, you can actually go ahead and abuse the fact that the Vy at the peak is going to be 0. It's a very nice tool to have in your belt. But first, before they do all that, when it comes to my scenario diagrams, I draw the arrow for the velocity over here, and I'll put V naught and my theta in there for both of these. And what ends up happening is we're going to go ahead and calculate the horizontal component of the initial velocity. I take my velocity right here, and I go ahead and use Vx is equal to V naught cosine theta. I get there because I know that I want the adjacent side of this angle, meaning that I'm going to go to cosine because I can see that's adjacent. Vx over V naught, adjacent over the hypotenuse. And then I have all those information, so I go ahead and plug it in and I get my Vx. And of course, this Vx, once I have it for all portions of my problem because Vx stays the same. Then B, they want me to find V naught y. I take the vertical component, the same process I had from before. Oh, heavens. I take the process I had from before. V naught y is equal to V naught sine theta. And now I'm left with finding the time to the peak. And like I said, when finding time, you might as well go to the y. 99% of the time. I can't help but spit right now. If I know V naught y, I know the velocity y at the peak. I know that's going to be 0 because it's at the peak. I know this. These are things that I need to know. This is a rule that you have to be familiar with. I don't know delta y. So because I know my initial and final y velocity, I will use formula number 1 to find the time. And formula 1, that's an easy one. That's a gift. If I isolate time, I end up getting the negative of my initial velocity over time, the acceleration. And guess what? The negatives cancel out. That gives me a positive time. Don't be scared. Don't be scared of negatives. For part D, I want to find the time. Oops. Is at the landing. I want to find the time it takes for the object to land. And because the launch and the landing, they start the same height, I can abuse the fact that the time interval to go from 0 to B is going to be twice that of the time interval to go from 0 to A or to 0 to the peak. And that's because they land at the same place. So I'm abusing that rule for that. And what ends up happening is I just multiply this time that I solved for in the other equation. And then multiply by 2. I'm not scared. I am not tired. It's a Friday. All the youths are gone. I'm putting this work in for you all. I had some old videos, but I had to make these new ones because the focus wasn't proper. And I don't like the way I formatted it. I'm always changing things up. For part E, I want to find the range. I want to find the range that it takes. So what I do is I find delta x from 0 to B. If I'm finding the range, I have to go to the x formula. I only have one option. You want the whole range, so I'm going from 0 to B. So that means I'm going to take the time interval that it took to go from 0 to B, which we found just in the last problem. Plug and chug, 9.6 meters. Okay. Lastly, they want me to find the height of the peak. In this one, I go ahead and I have a lot of options. I have y, I got time. I have y naught. I'm looking for y final or ya. I have the time. I have v naught y, I have vfy. I can use anything. But usually, because VFY is going to be 0, and I have final velocity in that third equation, I'm going to go and pick the third equation because I can exploit the fact that final velocity will be 0, and it'll make an easy little calculation. But it doesn't matter. You can do it either way. You can't go wrong at this point. You just have to pick, and you just have to persevere and keep going. I isolate it. If I isolate delta y, given my third equation and everything that I know, then I know the initial velocity at the bottom in the y direction. Then I know the acceleration. And I get that delta y is 0.63. Physics is easy. AP Physics 1 is an easy class. You have this. You can do this. You are capable. It's just some ballistics, a little bit of algebra. If you remember your rules as to when things are 0, you know when to multiply by 2. The rules are there for you to exploit them, and it's very valuable to have those under your belt. So I would focus on understanding those rules, and these scenario diagrams I find extremely helpful. It makes it take a little bit more time, sure, but I can't get it wrong. Even when things get very complicated, it's hard for me to get one of these questions wrong if I have the scenario diagram. And that's why I put so much emphasis on it. When things get more convoluted, it's going to be tougher to see, and you can't really do stuff in your head. So that's why I put such an emphasis on it. Good luck. I'll see y'all on Monday or Tuesday if you're in period 3. Bye.